Stanford University.
Okay, well, welcome to Stanford CS193 winter quarter of 2017. And today I'm going to continue that demo that we started last time. I'm really just going to enhance it to be multiple MVC again. Gives you a chance to see it all happen again. I'm going to be going very quickly for doing that because we already did that in the last demo, and you did it on your homework, so hopefully it's really, really comfortable. I'm going to dive back into the slides and solve a problem that we're going to have with our app, which is that it's really slow. Okay, and not only really slow, but it blocks our user interface so that the user thinks the app is probably dead and needs to be killed or something. And we're going to fix that with multi-threading. So I'm going to talk a little bit how we do multi-threading. I'll go back to the demo. We'll fix it with multi-threading. I'm going to show you a couple other cool things to do. And then we're going to come back to the slides, and I'm going to talk about text field, which is a little bit of a random topic, but I have to fit it in somewhere. And if I have time at the end, which I doubt I will, but if I have time at the end, I'll actually get started on table view, which is going to be our big topic for Wednesday. Very important topic, and it's what your next assignment is going to be about. Your next assignment has multi-threading as well, of course, but it's mostly a table view assignment. So that's what we're going to do today. So let's jump right back into our demo from last time. You remember that it looked like this. Okay, so here it is running, and this was a nice little basically image viewing application so far, and we can zoom in and out and pan around and all that. And in fact, in building this application, I've built this nice generic image view controller, right? It's a reusable MVC, just like in your assignment, you built a reusable graphing view controller. Well, I've built a generic MVC that will show an image and let you zoom in on it and pan around. So that's kind of cool. And I'm going to, well, first of all, hopefully you're gaining an appreciation for good API design and how important good API design and reusable componentry is to building good architecture in general. So hopefully you're seeing that. I mean, these are very simple applications that we're writing, so it's hard to see, but when you start building a huge app and have these reusable components and really strong public APIs that you're willing to support and things like that, then you'll find that your application is going to have less bugs and it's going to be able to grow over time, and you're going to be able to work in teams better, so it's just good all around. I did put a little, in my view did load, remember this? I put that little image URL equals demo URL, that Stanford. That was just for testing. And now that we know it works, I'm just going to delete that so that my image view controller, again, can be reusable. This is its public API, which happens to be its model. It's not that unusual, by the way, for the public API of a view controller to set the model. But that's quite actually common. So that's our model. It's the URL for the image we want to show, and it's public. So we're going to be using that when we build the rest of our app. So our storyboard so far just has this one image view controller right here, and I'm just going to rapidly go through and build a multiple MVC app. What we're going to do is just use our generic image controller MVC here to view images related to the Cassini project, which is a space probe that was sent out to Saturn. And so to do that, it's going to be all the things you know. I'm going to build another MVC. So here, let's drag out another MVC. Let's create a class for it. I'm going to call it, it's a Cocoa Touch class, of course. I'm going to call it Cassini, my Cassini view controller. Okay, I'm going to put it in the same place that I put all my other files here. And here's my Cassini view controller. I'm going to remove my view controller lifecycle, but I'm going to leave my prepare for segue without the comments because I am going to be segueing from this Cassini view controller to my image view controller. So the way this UI is going to work is I'm just going to have 3 buttons here in Cassini, similar to how we had with the emotions application. And these 3 buttons are going to pick these 3 URLs right here that are from NASA here, jpl.nasa.gov. One's of Cassini itself, one's of the Earth, and one is of Saturn. So we're just going to have 3 buttons that let you pick those 3 images. All right, so let's build that UI. I'm just going to grab a button here. Oh, first of all, let's make sure we set our identity. We just dragged out a generic view controller. We obviously want its identity to be a specific subclass. In this case, the Cassini view controller, just like this one is an image view controller. All right, So let's drag this out. Let's make the button a little bigger. Let's get a bigger font. Try maybe 40 point, something like that. Again, the 3 buttons I had, one was Earth. I'll just do copy paste, make a couple more buttons here. Another one was Cassini itself. Another one was Saturn. And we'll just select these and we'll put them in a stacked view and we'll put some spacing between and we'll fill and fill equally. We'll take it and drag it to the middle here. We'll use our blue lines to put it in the middle so that we can go down here and say reset to suggested constraints. We can go to our size inspector here just to verify that the constraints it added seem like the ones we want, which definitely does seem like that. Let's go ahead and one thing I want to show you a little different this time is before we started with a split view controller and then I added the navigation controller in. In other words, I started with an iPad UI, building an iPad UI, and then I made it also work on iPhone. We can do the other way around as well. So we could take this view controller, which is the base one that we want to show, and we can say embed it in a navigation controller. Okay, and then obviously we want to make this navigation controller be the entry point of our app. Don't want to forget that, so I'm going to throw that little arrow over here onto the left. And then when we do our segues here, like from Earth over to here, and from Cassini, and I'm doing show detail because I know eventually I'm also going to support the iPad instead of show, which would only really support the iPhone, because show, remember, if you do a show and you're in the master of an iPad, it'll actually, if you're in a navigation controller in the master of the iPad and you do show, it's going to replace the master, whereas show detail replaces the detail. So here I have these 3 segues. I'm going to kind of cheat a little bit and have my segue identifiers just be the names of these URLs right here. So Cassini, Earth, and Saturn, that's going to be my segue identifiers. I say it's cheating because normally your identifier would just identify the segue and then you would get the information somewhere else, but just to make our code really, really simple. Oops, that's not Earth, that one's Saturn. And then let's go to this one. That one's Earth. And we go to this one. Oops, this one rather, that is Cassini. Okay, so we built our UI here. Now this would be really only an iPhone appropriate UI. If we run this on iPhone, it actually would look fine, you'll see. Now, why doesn't this work as is? You see I had this right here, and I get this modal view. It kind of came up. Obviously, we have no image selected yet. We haven't written any prepare code, but there's no back here. Why is there no back? That's because of these things being show detail. Okay, because show detail only works in the iPad configuration. So like if I change this to being a show, well, I'm not sure why. Maybe I have to remake. Someone was saying this too. Let me have to remake that one to be a show. Let's see if that works. Oops, where'd it go, Saturn? Actually, it doesn't even matter what we call it there because we're not doing any prepare. All right, see, so now it pushes. We're inside the navigation controller. We can go back. Okay, but this is iPhone only, and we don't want that. Okay, we want to work on both platforms, so I'm going to take that out again and put this back to be show detail. But anyway, so I have this nice iPhone API, or a UI rather, and I want to turn it into split view, so I'm going the other way in terms of preparing it. So let's go down here and grab a split view. Okay, I drag it out here. Remember, it brings all this other junk with it. We can close our document outline. We can delete these things that came with it. Okay, and now we have our split view controller right here. And we can just use control drag to make this be our master. And we can put this down here, let's say, and control drag to make this be our detail. And let's make our entry point, oops, be the split view. And just like that, now we've turned this into something that can work on iPad. But having these segues be show versus show detail is kind of an annoying little difference between the two platforms. So you kind of have to know whether you're going to put it in a split view or not, unfortunately, when you build your app. And now this will still work on iPhone. Okay, it's showing the detail to start, and we can navigate here into these various things. And it will also work on iPad. All right, so here's the thing. We can slide out our master and click on these things, or we can go to landscape. And again, it's not showing anything because we have on the right. Now again, on iPad, maybe we want to put this in a navigation controller right here, so we get a nice title over here, so I can do that as well. Just go down here and select this view controller down here and do embed in navigation controller. Now, if we do that, we're going to want to be careful in our prepare that when we prepare for the segue, we account for this navigation controller perhaps being there, and I'm going to show you how to do that as well. All right, so let's do our prepare. We've got our UI, same kind of UI as we did in Motions, exactly the same, but obviously nothing works in these segues unless we prepare. So let's go to our prepare for segue here and type it in. It's going to be a really simple prepare for segue because I made the segue identifier be the thing I'm going to look up in the table. So I'm just going to say if I can let the URL that I want, the NASA URL, equal demo URL.nasa. Okay, and then I'm going to look it up by taking the segue identifier. But if that segue identifier was nil, this won't work. In other words, you can't look up something that's an optional, like the identifier is, in a dictionary. This dictionary is looking for a string here. So I'm just going to say defaulting to nothing. And of course, looking this up in this dictionary is going to return nil, but I'm doing if let right here, so that's okay. So now I'm getting the URL if possible. So if that segue, if it's possible to get that URL out of the NASA dictionary, then I will do that. Now, of course, I need the view controller that I'm segueing to. So I'm going to say if I can let image view controller equal the segue's destination as a image view controller, right? That's that view controller that we're segueing to. So if I can do that, then I can prepare. But of course, here we've got the problem where this destination on an iPad might be what? A navigation controller. So normally we would put a little if in here. We'd say if the thing is a navigation controller, then we would get the visible view controller. Remember that code that we put in there? You probably put that in your homework if you used navigation controller for your detail. Instead, I'm going to put that in an extension. Remember we learned about extensions last time? So I'm going to extend UI view controller and just add a var to UI view controller. Now this var I'm going to call it contents, and it's going to be of type UI view controller. And since it's in an extension, it can't be a var that has any storage, right? Extensions have no storage, so it can only be a computed var. So, okay, I'm going to compute it. And what is contents going to be? What is this var? Well, I'm defining contents to be the contents of this view controller, what this view controller holds. Well, if this view controller is a navigation controller, then that's the visible view controller. If it's not, then it's just itself. Okay, a view controller's contents are itself, unless it happens to be a navigation controller, and then it returns a visible view controller. I could also probably check to see if I'm a tab bar controller, and if I am, show the visible tab too, but for the interest of time, I won't do that. You could do that if you want. So I'm just going to say here, if I can let navcon equal myself as a UI navigation controller, in other words, if I'm a navigation controller, then I'm just going to return the navcon's visible, but navcon is myself. It's just that it's myself as a navigation controller, so I can send this var, I can get this var from it. Of course, visible view controller is optional because the navigation controller might not have any view controller in it at the moment, so I better have a default there, which I'll just return self. Okay, and then if I'm not a navigation controller, then I'm just going to return, I'm just going to return self. So you see how contents, it's showing the contents if I'm navigation controller, otherwise it's returning myself, which is kind of cool for this situation. And it allows me to go up here, instead of saying segue destination, I can just say segue destination.contents. And then I don't need this little if up there. Now, is this a reasonable thing to do in an extension? Absolutely it is, because this var has complete and utter understandable semantics that only have to do with a UI view controller and nothing to do with Cassini view controller or anything else. And when you do an extension, you want that to be the case. You don't want to generally put extensions on other classes that have to do with other classes generally, unless they're kind of like standard types or something like that. Maybe converting from a string to a date or something like that in some way might make some sense. But you wouldn't want to put extensions on other classes that are specific to things that other classes need. In that case, just put a function in your own class that does that thing. Okay, so everyone see what I'm saying about this? This makes perfect sense. This would be usable in any environment. It's a sensible var to have on a view controller. All right, so now that I have my image view controller, okay, either by getting it or going through the navigation controller, I can prepare it. And so preparing it is really easy. I just want to set the URL equal to that URL. Okay, the URL that I got out of the demo URL. This is its public API. Okay, it happens to be its model. Let's also set its title. We can set the title equal to, we could do the same thing we did before. Take the sender, interpret it as a UI button. And if we're able to do that, then we'll get the current title, which might be nil, but that's okay because this is also an optional. This is optional, so it can take a nil, even though this is nil. And of course, it might be nil because this turns out to not be true. That's fine too. See how these optionals play out nicely because you have vars that are optional and things are optional. So you can set things equal to each other and kind of just all plays out kind of beautifully there. All right, so that's it. Let's run here, see what we got. Okay, so here we go. So let's take a look at Cassini, for example. Oh, look, it's broke. Oh, no, it's not broken. Oh, it is broken. Whoa, what's going on? Okay, I clicked there to get Cassini, which, oh, look, there's Cassini. Oh, let's zoom in on Cassini. Oh, there it is. Okay, so this is the Cassini space probe right here by Saturn. But when I clicked on it, it seemed like my UI froze. And if I click on these other ones, look, I'm clicking Saturn, Saturn, Saturn. Nothing's happening. Oh, now something came up. Okay, so this UI seems broken. Now, we're on ultra-fast network here. This is Stanford's network. We have like gigabit connections to everywhere. And it still took a while because this is a very large file. Imagine I was on cellular. Okay? That image might take a minute to download. And meanwhile, my app is completely stuck. I can't click on any other button. If I'm on iPhone, let's see what it looks on iPhone. It's even worse. If I'm on iPhone, I'm going to click that and I'm going to think, oh, my app is broken. So I'm in your navigation controller, no problem. I'll just hit back. But even the back button's not going to work, as you'll see. All right, so here we are. Got the detail view there. Okay, now I'm going to hit Earth. It's stuck. Okay, and again, I can't do anything. It finally comes back. So this kind of UI is horrible because, especially on cellular or something where it's really slow, users are like, this app is broken. They're literally going to, double-click the home button and flip your app off, to use an analogy there. They're going to flip your app and kill it because they think it's broken. Okay, so we're going to fix that with multitasking. So first, let me show you how that works. All right, so multi-threading. There's two reasons, generally, that you want to do multi-threading, okay? One reason is you have a mathematical problem or some image processing problem that is best solved using some kind of parallel processing algorithm where you want to go off and do 1,000 things or 100 things at once, and then when they're all done together, you're going to combine the result or something like that. Okay, so that's an obvious need to do multi-threading. That's not the multi-threading I'm going to be talking to you about, okay? That's perfectly valid use of multi-threading, and iOS has some great API for doing that kind of design, but that's not what I'm talking about. The second reason that you might want to do multi-threading is because you have one thread. By the way, does everyone know what a thread is? Raise your hand if you know what a thread is. Okay, I see some people saying, yeah, remind me. Okay, well, a thread just means thread is short for thread of execution. And it just is kind of the process through which code is executing, all right, that could conceivably be separated where you have multiple of them. For example, in the iOS, you've got a very important kind of main thread of execution. That's the thread of execution that is listening to gestures and doing drawing, things like that. Then you can have other threads of execution that might be doing background things like going out onto the network and getting data or something like that. Now, most of our devices aren't multiprocessor per se, so these threads, although they have multiple cores, so they can actually do two things at once. They literally can. But in this case where I'm talking about multi-threading to solve this problem of keeping the UI responsive, we don't even care about that. And so here's the thing with multi-threading and the UI. We want the thread of execution, which is listening to the user, to be super responsive, always working, never blocked. Okay? And we don't really care about other threads too much, but we really want that one to be unblocked at all times. So if we're ever going to do anything that would block, like either block because it's doing so much computation that it's not getting back to the rest of the code, or in this case with our Cassini, it's going to block because it's waiting on some resource like the network. Okay? I make a request for a URL, it doesn't respond immediately, I have to wait. Okay, well, anytime I have to wait, I can't be waiting in the middle of that UI because now no one can do a gesture or click on the back button or do anything else. All right, so that's the kind of multi-threading that I'm talking about here that we're going to try and solve, is keep the UI thread responsive and active by pushing everything else that could be slow or block waiting on a resource off to a different thread. Now, in iOS, we don't actually even really talk about threads much. I've been using this word thread. Okay, because that's what's going on underneath the covers. We're talking about threads of execution here. But really what we talk about is queues. Okay, so multi-threading is really about queues. Now what's a queue? Okay, a queue is an English word actually. We don't use it in the United States much, but a queue just means a line. Like if you go to the movies, you might say, I'm queuing up to see this movie, especially if you're in London, you would say, let's go queue for the movie. So that's all a queue is, it's a line. And what are we going to put in this line? Instead of people waiting for the movie, we're going to put blocks of code. Okay? And we know a great way to make a block of code that we can put in a line, which is a closure. So we're almost always doing this with closures. We're putting these closures, it could be any block of code, but we're putting these closures basically, usually, into a queue. Okay? And so what's happening then is the system is creating threads as necessary to grab those blocks off that queue, off the front of the line, who's ever in the front of the queue, and executing on a thread. Okay, that's how multitasking or multi-threading really works in iOS. We don't really care how the system assigns threads to these lines, these queues. All we care about is the queues. And when we want to express to the system where we want things to run, you know, where the UI runs or in background process or whatever, we specify by what queue we put code on. Does that make sense? All right, so let's talk about the queues that we can have, all right? One important queue, of course, is the main queue. So this is the queue on which all the UI activity is happening. It's not only the queue that all UI activity is happening in general, but it's the only queue that UI activity can happen on. And that's because it's a serial queue. A serial queue is a queue where the blocks of code are waiting in line to run, and there's only one thread to run them. So when the system comes along to grab the next guy in line, he runs him to completion and then goes back for the next one. So you see how they're serial, right? They happen in order. The entire line of closures waiting to run or code waiting to run is processed in order, one at a time. Okay? Now, what's really great about the UI side of that is it makes it very predictable. You really don't have to get into a lot of the mind games of multi-threading where it's like, is this thing waiting on this? Do I have to have a lock on this data resource? Blah, blah, because all the UI stuff is all happening in the main queue. This is all happening serially. You never have to worry about two UI things accessing the same data structure at the same time because they're all just marching in line down this main queue. Okay? So all UI activity and only UI activity, no other stuff generally, runs in the main queue. And the reason we don't want other stuff running in the main queue is we never want the main queue to be blocked. Okay, we never want it to be off doing some computation or certainly never blocked waiting for the network or something. So that's the main queue. That's the most important queue. And then there are these other queues. Now, I'm going to talk first about the global queues. The global queues are different kind of queues. Okay? These global queues, people wait in line to go on to those, and at the other end of the line, the system has multiple threads ready to go. And it can pull a closure off the line, give it a thread, it starts running, pulls another one off. It starts running before the first one's even done. So those are called concurrent queues. Okay? Queues where you could be pulling people off the line because you got multiple threads to assign to the task. All right? So things we do outside the UI, like network things and things that block, we're generally going to do those in these global concurrent queues. Okay? Now, you can also create your own serial queues and your own concurrent queues. We'll talk about that in a couple slides. You're not going to need to do that in this class. 90% of the time, you're either using the main queue or you're using one of these global concurrent queues. So let's talk about the code. How do you get a queue? I need a queue because I want to put a block of code on this queue. I want it to get in line to go run. Well, the main queue, you just use this var dispatch queue.main. Okay, it's a static var, a class var on the class dispatch queue. And that's it. You have your main queue. Couldn't be easier. Now, getting one of these global concurrent queues, a little bit more work. You're going to use dispatch queue.global instead of dispatch queue.main, and it takes an argument there, QoS. Okay, QoS stands for quality of service. So this is talking about what the quality of the service that the line is getting, okay? So high quality service means things are being pulled off the line really fast, and the threads that are being used to execute them are high priority threads that get to run a lot, okay? Because remember, there's only one processor, so they all have to kind of share the processor. So high quality service means you get a lot. Low quality service is, well, the system will pull your thing off when it feels like it, like maybe the phone got woken up for some other reason. It's not going to wake your phone up to do it, and it's certainly not going to, block any higher priority thing, that kind of thing. So, but the quality of service is not like a number, 0 low quality, 10 high quality. Instead, it's kind of a flavor of usage. These are the 4 qualities of services here. So user interactive means the user is interacting with the UI right now, usually with a gesture. They are panning around or pinching, and you're forking off something into a thread to go do something. Now, this is usually not a case of the thing you're going to be doing is so intensive that it would block the main thread, because the person is panning right now. But it might be something that can't quite keep up with the finger, and you're going to deal with that by, in this other thread, trying to keep up as best you can and just updating the main thread as fast as you can, which might be a little slower than the finger's going. So, the thing you're dragging around, maybe it's jumping a little bit because you can't calculate its new position fast enough. But the point is, this queue really needs to run almost as fast, it's almost as high priority as the main queue because you're doing something interactive. Okay, the next one is user initiated. What this means is the user currently did something to initiate this activity that's going to be done in this queue. So it's pretty high priority. Okay, the user did something and they're waiting for a response, presumably. So that would be the category for our Cassini project. Okay, we clicked Earth or Saturn, we want that image now and we're waiting for it. So we are going to use user initiated. Okay, because the user initiated a request for it. But it's going to take a while. And the user's not interacting, we're not making it doing something different every time it moves. But it was user initiated. So user initiated is pretty high priority. Then there's background and utility. These are somewhat similar. Utility is truly the deepest of background process. This might be something you run once a week in your app. Maybe it cleans up the database by removing old crufty stuff. Something the user doesn't even know is going on. It's so low priority, it just kind of happens in the background. Background might be something that like maybe you're thinking ahead a little bit about the way the user might want to use your app, and so you fork something off in the background to go fetch some stuff or whatever. The user didn't ask you to do it, but you're kind of doing it, and you kind of want it now-ish, but it's okay if it takes a little while. So you see what that one is? So these are the 4 qualities of service, and you just need to pick which quality of service you want for your global queue. And then remember that the things you put on there are going to be run concurrently. So they can't really depend on each other. Okay, I'll talk about things depending on each other in a second. But you want to think about the things you put on these global queues as being these independent little things like go fetch this file. It's all self-contained, just give me this file. Not blocks that are going to be somehow depending on each other's results, because this is all concurrent. These things can be happening exactly at the same time, so you can't really, it's not serial like the main queue. Now, like I said, you've got this queue, and all we're going to do is put blocks on it, and we do that with these two functions, async and sync. Okay, these two functions take one argument, which is a closure, a function, but usually it's a closure. That closure or function takes no arguments and returns no arguments. Okay, and you can put anything you want in that closure. So async means put this closure on the queue, put it in the line to execute, and return immediately. So async does nothing except for put that block into the queue, whatever queue you send it to. Sync, same thing, puts it in the queue, and then it says block this thread until that closure finishes executing on whatever queue it's on, okay, which could be a totally different queue. So basically, the sync is block me until this closure finishes executing wherever you put it. Okay, so you would never do sync on the main queue, because we never want to block the main queue. So you would never say main queue.sync anything. Okay, but you might have other queues and say, you would say main queue. You could say main queue.sync, but you would say it on another thread, right? You fire off some other thread, it's running along in the background. It could say main queue.sync this code. Now that code would be put on the main queue. Sometime later, we don't know when, it would run on the main queue. Once it's done, then your thread, your queue that issued this, would continue. Okay, make sense? So sync, we would only do this sync from code that is not on the main queue, because we never want to block the main queue. Question? Yeah, so the question is, when I say sync, am I saying let this block, this closure go first or something? No. Okay, this has nothing to do with priority. The priority is the quality of service. I'm just saying put this queue, this closure onto the end of that queue. Okay, now whatever queue it is will have some quality of service, and it will eventually get to this thing. In the meantime, while all that's happening, this queue that this code is in is waiting. It's blocked. Okay, it's just blocked, waiting for that closure to finish. How that closure finishes depends totally on what queue you put it on and how much other stuff is in that queue and whether it's a concurrent queue, all those things, right? So, but this sync just means block me until that thing's done. Yeah, question? So the question is, does running multiple threads, having multiple things going in multiple threads, does it slow down the main queue thread, the thread that is running the main queue? And the answer is no. It does not, usually, because the main queue is getting a lot of high priority. So it's pretty much interrupting anything those other guys are doing whenever it wants to run. Okay, so if it wants to run, it pretty much gets the processor. The main queue is the highest priority thread that exists on the device. So it's rarely going to be slowed down. Now, I'm not going to talk about this, but yes, threads have overhead. If you created thousands of threads, that would start slowing down your computer. But again, that's why we don't really talk about threads. We talk about queues, and we let the iOS manage the threads because it knows how to efficiently manage thread pools and things like that. Okay, now you can create your own queues just using a normal initializer of dispatch queue. Instead of saying dispatch queue.main or dispatch queue.global, you say dispatch queue with the initializer that takes a label. That makes a serial queue. And that label shows up in the debugger. So in the debugger, if you pause and that queue is running a thread, you'll see that thread in the little debugger window on the left in the navigator with this name, this label. So it's just purely for seeing it in the debugger. And if you want to make your own concurrent queue, right, a queue that has multiple threads that can be working on things, then same thing except for you put attributes.concurrent in the initializer there. Okay? You won't need to do that in this class, and rarely do we do this. It's usually main queue and the global queues, 90% of the time. All right, I'm only showing you the absolute tip of the iceberg for multi-threading. I'm showing you the basic stuff you need to get stuff off of the main thread, but there is a lot more. You're going to want to familiarize yourself eventually with dispatch queue and all the things that it can do. This stuff is all based on something called Grand Central Dispatch, because when we put a closure onto a queue, we call that dispatching the closure onto that queue. you can do all the things in multi-threading. For those of you who do know about multi-threading, you can do all the things you can expect. Protecting critical sections, readers and writers, single writer, multiple readers. You can do synchronous dispatch, you can do locking, all the things you need to do, you can do. I'm not going to talk about any of that, but it's all there, okay? There's another API for doing multi-threading, operation queue and operation. These are classes or structs, I guess they're classes. And you'll see those occasionally in iOS API, kind of older iOS API. But for the programming you're going to do, again, unless you've got the kind of multi-threading problem, which is doing a parallel processing thing, not the kind of problem where you're getting something off the main queue. Operation and operation queue are nice because it makes it easy to make dependencies, where you say this block of code depends on this one running first. I need the result from this one before I can do this one. Right? So you can set up those relationships. Then you can say, OK, now just start running them. And the system will make sure this one gets run before this one, et cetera. All those dependencies. So that's operation and operation queue. All right. In iOS, you'll see certain methods that are multi-threaded. And you'll see that in the documentation. You'll read in the documentation. And the way it works is you're going to see a method that takes a closure as an argument, and it'll say in the documentation, this closure is run on another thread off the main queue. And when you see that, you have to go, oh, uh-oh, because any code I put in that closure that I'm passing to this function can't be doing any UI stuff, because that only can happen on the main queue. And this happens quite a lot, that we have a closure that we're putting on some background queue or passing to some iOS function that says it's not going to put it on the main queue, but we still want to do UI stuff. So how do we do that? We just dispatch it back to the main queue. Okay? And this is what that looks like. Here is an iOS API that takes a closure as an argument, and it runs that closure off the main queue. Okay, it's called NSURL session. It's used for getting the contents of URLs. Now, you saw in our image view controller demo so far that we already know how to get the contents of URLs. We just use data contents of. Remember we said try data contents of, and it blocked the main queue while it went and got that URL. So that's one way to do it, but it's kind of non-configurable. What's cool about NSURL session is, you see that argument there, configuration default? Well, you can change that configuration. For example, you could say, I'm going to fetch this URL, but don't fetch it over cellular. Only fetch it if I happen to be on a Wi-Fi network, for example. Okay? So you can configure how you want this fetching to happen. So it's kind of a more powerful way of fetching than just saying data contents of. And the way it works is you create an NSURL session with a, it might be called URL session these days. Yeah, this is an old slide, but so it's just called URL session and URL, not NSURL. You create one with a certain configuration, then you get the URL you want, and then you call this method data task with URL and closure. And what this does is it creates a data task object, okay, with that URL that you want to get. And when it goes off to fetch it, or it will in a minute, and when you send it off to fetch it, when it comes back, it will call this closure, and this closure has 3 arguments. The data it got from the URL, the NSURL or the URL response, and then some error if some error happened trying to get it, okay? So that closure. So this closure is interesting because the documentation will tell you this closure does not run on the main queue. So that's a problem, because what if, oh, and sorry, by the way, that resume, task resume at the bottom, that's what actually causes it to go do the fetch. So the data task really doesn't do anything but create the task, and then when you say task resume, it goes off to fetch it on some other thread. It doesn't block, okay? Task resume does not block, obviously. So when the data is gotten and that closure is finally called on some other queue besides the main queue, you want to do some UI in there, like you want to show the image that you just fetched or whatever, and you can't do it because you're not on the main queue. So how do you fix that? You just put inside of this closure that you put right here another dispatch, okay, back to the main queue, right? Dispatch queue main async with a closure. And you put your UI stuff in there. Now it's going to happen back on the main queue. All right, so let's go through. I want to show you the timing of each of the steps of this code right here so you can see what's happening when, okay? Because multi-threading is really a lot about when. And it's the when that can confuse people when you're doing multi-threading. So obviously the first line of code is that let URL, get the URL, so now I have the URL. Next we're going to create this data task. This line of code, line B there, returns immediately because all it does is create that data task. It doesn't actually do anything. You pass the closure to it, but it's a non-escaping closure. It holds on to it, right? This data task thing holds on to it. Then you do task resume. That also returns immediately, but on a different queue, it starts doing the fetch. It starts trying to get the contents of that URL. Okay, but on some other queue. So that's why on this queue, this is the main queue presumably, it is returning immediately. Task resume returns immediately. So that means that line H happens immediately. Right after task resume, boom, the print, done firing off the request. But that's all we've done is fired off the request at this point. Okay, the next line of code that's going to happen after this one is this one. So after the URL contents come back, now this closure is going to execute. And so we're going to have line C be executed. So A, B, G, and H, they executed boom, 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 run right after each other, no delay. Then there was a delay while we went and got the URL contents. That could be a long delay. That could be a minute or more if it was a big file over cellular or something like that. So this line of code C, you have to be careful. It could happen much later, and by the time it happens, you may not even care anymore. Okay? If you had a really slow network, a big file, by the time you come back, the user, they're like, I don't even care about it. So they're gone. So when you come back to line C right there, you better check and make sure that you still even care. Make sense? All right, next thing that happens is we want to do some UI stuff with the data we got back. But of course, to do that, we have to dispatch to the main queue. This line of code, line D, also returns immediately because it's an async dispatch. Okay? All it's doing is putting that closure onto the main queue. So this is the next line of code that executes. Notice line E has not executed yet. Okay? Line F executes, and it just says, I did some stuff with the data, but the UI part hasn't happened yet. I put it on the queue, but it hasn't been executed yet by the main queue. Okay? And then, finally, the UI stuff gets pulled off the main queue and executed. Does everyone understand that process? So to summarize, it's A, B, G, H, C, D, F, E. Now, the thing about this, there's actually not necessarily exactly this way. Because when you dispatch things to the main queue from the main queue, they could run right away. Okay? So it is possible that E could happen before F. But if this was on some other queue besides the main queue, it's very unlikely that E could happen for F. But it even could then, because the main queue has so much priority that when you dispatch something onto it, the system might immediately go and try and process it. Okay, that's how high a priority the main queue is. So it's possible E could happen before F. But I just want you to think conceptually that when you put something on the queue, you kind of put it on the queue, it could happen later. There might be other things on the main queue ahead of you. Okay, so it definitely wouldn't run right away then. Okay, so that's the timing of multi-thread. So let's go back to our Cassini code and make it so that it uses these queues to stop blocking the main thread and stop being all stuck like that. All right, to do this is actually remarkably simple. We're just going to go back to our image view controller. This is the deadly line of code. I even put a comment in for this line of code when I posted this last time so that you realize that this is a terrible line of code. This line of code, if this is in, from now on, if you turn in homework with a line of code like this, you're going to get major dinged because one of the evaluation criteria now is going to be no more blocking the main queue. You cannot block the main queue. Okay, that's an evaluation criteria of all the homework going forward and of your final project. All right, so we have this terrible thing, and we can't do this line of code like this because it blocks the main queue. So what are we going to do? We're just simply going to put this call on some other queue. Okay, and I'm going to do that by just saying dispatch queue.global. Okay, I'm going to get a global, one of these global concurrent queues. And it's asking me for the quality of service, and the user initiated this request. Okay, but it's not interactive, so I'm going to say user initiated. Okay, so the choices there. Now I've got the queue I want, and I'm just going to asynchronously post this code that I want to do, this code that blocks onto that global queue. And at some point, that global queue is going to allocate a thread and grab this closure off it and start running. Now, it's going to happen pretty darn quick, but not necessarily instantly. So now I've solved the problem. Woohoo! It's off the main queue. I'm no longer blocking the main queue because this, which is executing on the main queue, because all of this code is on the main queue, right? We're executing all of our codes generally on the main queue. This returns immediately. It's async, so it immediately returns. It just puts that queue, that closure on the queue, and returns immediately. So no blocking the main queue. Excellent. But you notice I got this little error here. Let's take a look. What's that thing? Oh, yeah. Reference to self inside a closure. You have to explicitly put self so that you think about memory cycles. And indeed, there is a bad memory cycle here. Because this closure, if you'll remember, this is happening because I clicked on Saturn or Cassini or Earth, and it went off, created an image view controller for me, and that image view controller is being put on screen, and it's going off to fetch this thing. Now, what if the user is like, I'm tired of waiting for that Earth image, and they hit back and go click on Saturn? Okay? When they hit back, what's supposed to happen to that image view controller? Anyone? It's supposed to leave the heap, okay? Because it was under navigation controllers on the top, and I hit back, whoo, toss it out. But can it leave? No, because this closure is keeping it in the heap, even though I don't want this anymore, okay? I went back because now I'm going over to see Saturn instead of Earth, so I don't even want this Earth thing anymore. So this is a bad kind of memory cycle, because this is going to keep that image view controller in memory, so that's bad. So this doesn't want to do this, so we're going to fix this one using weak self. By the way, I showed you do weak self equals self, but I am personally a fan of when you're using weak on self to just say weak self. And all that does is inside of this closure, it makes self be an optional version of itself, okay, because it's weak now. So that means I have to do this, because if I do finally come back from this closure and the person has hit back, then the image view controller is going to have left the heap, and so self will be nil. Perfect, exactly what I want. And if self is nil and I do this little optional chaining, then this whole line of code is not going to happen. Exactly what I want. I do not want to create an image out of that information that came back, because that image view controller left the heap. So here I've broken this memory cycle beautifully here. Now, this does beg the question, surprised no one has raised their hand. Okay, well, how do I interrupt this closure? When I hit back and that image view controller goes away and I'm not interested in Earth anymore, I'm still finishing the fetch, okay, of Earth. And the answer is, you can't stop a closure that's been put on a queue, okay? You cannot stop it. The only way it can stop is if it quits itself. So it could be looking at some global state to see if it's still relevant, and if it sees, oh, I'm not relevant anymore, it could return. Right? So if it was doing some long-running thing, it could do that. Or you can use something like NSURL session, which is really smart about going and getting URLs, and it knows how to be interrupted and all the things like that. So you could use something a little smarter than just this one line of code. But once this goes on the queue, it's going to run. Okay? So it's up to it to decide not to run. Okay, so we fixed that problem of it, but there's still more problems in here. Okay? So what happens if this takes a minute or 10 minutes because slow network or whatever, and we get back, and in the meantime, someone called this on my image view controller. Now, our Cassini can't do that, but you could imagine an app that would be showing something in the image view controller, and then you click on something in the image view controller itself, and it shows a different URL. Okay? So someone calls this. If I call this again, it's going to go down here and fetch image again, which is here, and it's going to dispatch another closure off to go get the new image. Okay? So now there's two closures out there fetching. Now what happens when the first one comes back? What do I want to do with that image? Ignore it, right? Because the person said they want a new one. So I better put something in here after this comes back to see if I even care about that anymore. So, which is easy. I could just say, for example, image equals self.image URL. Okay, so, sorry, URL equals self.image URL. So I'm just going to look at this URL, which is right here, got captured by this closure. Okay, this closure has captured this URL. I'm just going to check if that URL equals whatever our current URL is. And if I'm not there, then it's okay. It's going to be nil, so it's not going to equal nil. And there we go. So here I just put a little test in there to make sure that I'm still interested in that URL. And everyone understand what's going on here where URL equals image URL? This is a constant that got captured here. So it's always going to be the URL that we went and got the contents of. See that? Okay, there's yet another problem here. Can anyone tell me another problem with this code? Obvious problem. I just showed you in the slides. This right here, self.image, is going to call this code down here. That's going to do all kinds of UI stuff. Okay? It's going to set the scroll view's content size, size to fit the image view, set the image view's image. This is all UI stuff. Where does that need to happen? On the main queue. Okay? And is this on the main queue right here? No. This is on this queue over here, this global queue, user-initiated global queue. That's where this is all happening. So that's not the main queue. So that is illegal. That's going to cause all kinds of weird behavior in your app if you do that. But easily fixed, we'll just dispatch queue.main.async and put this back on the main queue. Now, what's really cool about this syntax, I guess you would say, of doing these things is it looks very much logically like normal code, right? It's almost just like if-thens or whatever. However, you do have to understand that when you do a dispatch like this, that's going to happen asynchronously. It's going to happen in a different time than the rest of this code. Okay, same thing with this one. This is going to happen at a different time. Now, of course, things that you put on the main queue tend to run pretty quick, but even so, you just have to be cognizant of the fact that even though it looks like this line code's going to happen, then this line, then this line, then this line, then this line, it's not going to happen. It's going to happen more like the slides, right, where things happen a little bit out of order there because things are happening asynchronously. Async means asynchronously, out of time, right? Different, not lined up in time. Okay, everybody got that? Okay, so let's see if that fixes all our problems. So remember, okay, so here we have no image here. By the way, this is a terrible problem right here where this comes up blank. And I actually mentioned last week that I was going to make it extra credit for you to figure out how to not make this blank in your calculator, have it come up with the calculator instead of an empty graph. But I decided instead I'm going to show you how to do it today. Okay, that's why I didn't make it extra credit in the assignment. But anyway, so here's the detail. We haven't picked an image, so it's blank. Now I'm going to go back. Here's our Cassini view controller. Now I'm going to pick Earth. And it's loading up, but I changed my mind. Saturn, changed my mind. Okay, so I can change my mind now because those things are being fetched in some other thread. Now, if I wait long enough, they get it and return it. Okay, and so here I am. I have Cassini here, right? If I go back and hit Earth, again, I give up. Saturn, I'll wait, and we'll see. Get Saturn. Okay? We got that? By the way, Saturn, this is kind of a weird... I don't think Cassini took this photo here. It's a picture of people, but we do it. Oh, look at that. It's Saturn. Okay, one thing about this app, though, that's kind of bad is I click on this, and it's just get this white screen, okay, especially on a big image like this one. You get this white screen, it's white screen, it's white screen. It's like, what's happening in this app? I don't even understand what's going on, okay? So it would be really cool if I could give the user some feedback about what's happening, okay? Now, this feedback might be something that says loading ... or something, but a really cool feedback when you're waiting for something is a little spinner. Have you seen those spinners? A lot of apps have this where there's a little spinner. So let's add a spinner to our app so that when we click here, it's a little thing spinning until an image appears and then it goes away. Okay, that turns out to be incredibly easy to do. because that's a common thing to want to do, is to give the user feedback. Yes, I heard you, and I'm working on it, but I don't have it yet. All right, so how do we do that? Let's go back to our storyboard. And this is where we're going to want to do that, is on this view controller right here. Right, this is where our scroll view is with our little image view in there. And what we can do is just go over here and get an object. It's called an activity monitor. Here it is right here, an activity indicator view. And I'm just going to drag this into my UI, right in the middle. Okay? Now, what I just did there was a very bad thing. It looked fine, but it's very bad. And it's a little subtle as to why it's bad. So let's investigate this one in depth, why this was bad that I dragged that in there. And the way we're going to see that it's bad is by bringing out, for the first time, this document outline. Okay, this little thing in the lower left, which I told you we were going to talk about, and here we are talking about it. This is everything that's in our storyboard in outline form, okay, in kind of text form. And when we do this, we look down here at this activity indicator view. By the way, if you select something here, it'll select it here, and vice versa. So this is selected, so it's showing it here. And you see how these things, this is all the views. This is the top level view. That's the view var in the controller. Then here's that scroll view that we made. And then here's the indicator view. Well, you see how these are indented? That means they're subviews of each other. Okay? So we made the gray activity indicator a subview of our scroll view. We do not want that here. Okay? We want our scroll view scrolling around our image. We don't want it scrolling our indicator around. Okay? We want the indicator to stay in the middle. Okay? So we don't want it to be a subview of scroll view. We want it to be a sibling. We want them both to be at the same level, one in front of the other. And we can do that just by picking this up right here and moving it to the same level as scroll view. Now that's very hard to do in here, because anytime you try to pick this up and move it, it's always going to want to try and drop into a subview, a super view of something. So it's always going to grab onto it. But in this document outline, it's very easy. You can just pick it up and move it there. Okay? So when you do these activity indicator views in your future apps and in your final project, make sure you don't accidentally make it a subview of something that you drag it onto, if what you intend. Notice also the order matters here. This is the subviews in order, and remember that subview sub-0 is in the back, and all the other ones are in the front, so we obviously want this activity indicator to be in front of everything. All right, so that was that. Now what we want to do is we want to wire this activity indicator right here up to our code. Why? Because we have to tell it to start running. Well, actually, even before we do that, let's configure it a little bit. We've got it right here. We can inspect it. Here's the inspector of it. See, activity indicator view. It looks kind of small to me for this big view, so I'm going to switch to a different kind, which is the large white. But I don't actually want it to be white because the background is white, so I'm going to change its color to be, well, let's say blue. Okay, so this can be large and blue. Also, every time I stop animating it, I want it to hide itself, because I don't want it to be stopped spinning, sitting there showing. Anytime it stops, I want it to disappear. Okay, and then if I start it again, it'll reappear. So that's what this button is. This here, animating, would mean that it would come up animating, but I'm going to turn it on anytime I go do a background fetch. So I don't want it to come up with this view animating already. Okay, that's what those all mean. All right, to turn it on, I need to talk to it, so I need an outlet to it. So I'm just going to control drag from it, just like any other outlet we would make to a button or whatever. Here it is. I'm going to call it a spinner. That's what I like to call my UI activity indicators spinner. Okay, so there's my spinner outlet right there. And all I need to do here is turn this thing on whenever I go off to another thread to do something. All right, so here's where I go off to another thread to do something. So I'm just going to say spinner.start animating. Okay, and that's going to start it spinning. It's going to unhide it if it was hidden and start it spinning. Question? Animated just makes that, makes that little blue thing go around and around. It just makes it spin. That's what I call a spinner. Yeah, well, when I inspected it over here, okay, and I didn't click this button animating, that just means it doesn't start out animating. I have to start it in code. That's what this means. If I turn this on, then as soon as my app came up, it would be animating, which I don't want that. I don't want to start animating until I do this dispatch onto some other queue. That's when I want to start animating. Okay? Now, you might imagine that the place to stop animating it might be right here. Okay, spinner.stop animating. And this would kind of make sense because, you know, I went off to go get this image and it came back and I set the image. Now I can stop animating, right? But actually I don't want to do that here. And that is because I want to stop animating anytime the image is set. If an image is set in my image view controller, I want to stop animating. I don't care how it got set. If it got set from my thing coming back, that's good. If someone set it by saying image URL equals like a local URL, I want to stop then too. So I'm going to put it down here, an image. Here's where we set our image. This is the set part of it. And I'm just going to say down here, stop animating. So anytime my image is set, I'm going to stop animating. Because it would make no sense if the image was there and the thing was animating, right? That would never make sense for an image to be showing and it's animating at the same time. Because animating this thing means I'm waiting for an image. Got it? So that's it. That's all you have to do these spinners. They're super, super simple. They only make sense when you're doing things in other threads, the spinner. Okay? Because if you're not doing something in another thread, then why would you? See, now look, this came up. It's blank, but it's not spinning because I haven't asked for anything yet. So I'll go back here. Now I'll ask for earth. Oh, it says nil when doing optional value. Oh, that's not bad. What happened here? Oh, okay. Yeah, good one. All right, so this crashed. Why did this crash? Why did we have a problem here? And the answer here is that when I set this image, I was in prepare. Okay? And when I'm in prepare, my outlets are not set. So I need to optional chain that right there. Okay, so this crash, you'll get it yourself a lot, where you prepare something and crash. It crashes during prepare because you try to set your outlets. Now, this is fine for the spinner not to be set, and I'm setting the image because I never would have started it in this condition anyway, so all is well just to ignore setting the image when I'm preparing. Everybody got that one? You'll all have that hundreds of times in your iOS careers where you have some code that your prepare executes that uses an outlet. All right, so let's go back. Now we hit earth. See, it's spinning. As soon as the image gets put in here, it stops spinning, right? It's gone. Okay, back here, spinning. We don't want it. Let's go here. Skip it here. Okay? All right. Now, the last thing I want to do is this thing where when the thing starts up, it starts up blank. Okay? Right? It starts blank because it's on the detail. And I don't want it on the detail when there's no image URL there. Okay? I want it to start up here when I first start. All right, so how do I do that? I'm going to do that using the split view controllers. Okay, so go look at our storyboard here. I'm going to use the delegate of this split view controller right here. Okay, because the split view controller asks the delegate, would you like to do the job of collapsing the secondary view controller rather, the detail on top of the master? Okay, so it's going to give me the opportunity to do that. And what I'm going to do is, if there's no image URL in there, I'm going to say I did it, but I'm not going to do anything. And that's going to cause it not to collapse the detail on top of the master. Now, I need to have one of my view controllers be the split view controller's delegate. And I can't really have it be this one right here, because this one comes and goes. This is the image view controller. It gets created when it's segue to, and when you go away, it stops. It goes throw it out of the heap. So I can't have my split view controller's delegate thrown out of the heap all the time. So instead, I'm going to have this view controller be my split view controller's delegate. So here we go. Here's my Cassini view controller. Now, where's a good place to set yourself as your own split view controller's delegate? You could probably do it in viewDidLoad, and that would work. But I think a better, safer place to do it is awake from nib. Okay? Because awake from nib, if you remember from the view controller lifecycle, is called really early in the game. So if I want to set my own split view controller's delegate to myself, delegate, this is really early time to do it. Now, notice here that I'm taking my own split view controller, which might be nil, because I might not be in a split view controller, and I'm setting its delegate to myself. Right? Remember, every view controller has this var split view controller, which is the split view controller it's in, if it is in one. And so I'm getting an error here. Anyone know what this error is? Nobody? Okay. It says that you cannot assign a Cassini view controller to be a UI split view controller delegate. Okay, you can't make this equal to this. That's because this is Cassini view controller is not a UI split view delegate. UI split view controller delegate. We have to say that it's a UI split view controller delegate. Okay? Once we say that, that resolves this error. All the methods in that protocol are optional, so we've satisfied the protocol, which is kind of weird. But now we can implement any of the ones we want. Here's a trick for you. If you're a delegate and you want to find out what methods there are, just start typing the name of the class. So here's split view, and here's all the split view controller delegates. You have to have done this part first. You have to say you're a delegate first. Once you do that, it's going to show all these. Right? These are all the things split view delegate can do. And we want this one right here at the top, collapse secondary onto primary. So I'm going to double click that. I'll show you these arguments a little easier to see if I do this, that, and then this one. Nope. In the wrong place, that one. I'll even do that. Okay, so this split view controller delegate method has 3 arguments. One is the sender, that's the split view controller asking you. Here it's asking me, please collapse this secondary view controller, that's a detail, onto this primary view controller, that's the master. Okay, so this is what happens when we first start up. A blank detail gets put on top of the master, and we don't want that. But we only don't want that if that detail is blank. So I'm going to go here and say if the primary view controller is myself, because if the primary view controller is not myself, then things are gone weird here, but it should be. So I'm going to say if the primary view controller contents, because I might be in a navigation controller, equals myself. Remember, contents is this thing down here, right? So I'm doing that there. Then I'm going to say if I can let the image view controller equal the secondary view controller, that's the detail, it's this argument right here. It's getting passed to me. This is the thing it's asking me to collapse on top of it. Secondary view controller as an image view controller. And again, here I want to do contents, in case that's inside a navigation controller. Okay, but that's not all. It's not just if I have an image view controller being asked to collapse on top of me, but I want to make sure that that IVC's image URL equals nil. Okay, so if split view controller is asking me to collapse an image view controller that has a blank image, I'm going to return true to say, yep, I did it, but I'm not actually going to do anything because I don't want that to happen. Okay. So I'm kind of faking out the split view controller there. Otherwise, I'm going to return false, which means no, I couldn't do this collapse, so you do it. And now the split view controller will do it itself. Okay, so it's kind of funky, but I just wanted to show you this because kind of to show you that there are a little more complicated ways to do things than I sometimes show. But look what happened. I ran, and I did not get that blank view controller, right? Because I told split view controller that I collapsed it on there, but I didn't really, so it did nothing. But if I click on one, now the image URL is not nil, and so it did do the collapse for me. All right? So that's it. Okay, let's get back to our slides and do our last topic here, which is our text field. All right, so I'm just going to throw in text field in here because it's going to be included in our next demo and in your next assignment. It's a pretty easy little class, UI text field. It's very similar to UI label. The difference is it's editable. So a UI label, if you touch on it, nothing happens. But a UI text field, if you touch on it, a little blinking cursor happens, and you can, the keyboard will come up from the bottom, and you can use your thumbs and type, or if you have an iPad with a physical keyboard, you could type or whatever. So that's all a UI text field is. Now, because it's editable, it's got some little intricacies that are quite a bit different than UI label. It still has things like attributed text, and you can set the font and all these things because it's very much like a UI label in that way. But there's this keyboard, okay? When you're in a UI text field and you touch on it brings up a keyboard. So how does that keyboard show and not show? Well, the keyboard shows anytime any view in the view hierarchy becomes the first responder, what's called the first responder. The first responder means it wants to be the thing that gets key events from the keyboard. It's the first responder for key events, all right? And you can make a UI text field start its cursor blinking and make the keyboard come up by sending it the message, become first responder. Right? If you tell a UI text field to become the first responder, the keyboard will appear. So that's how you make the keyboard appear. And similarly, if you want the keyboard to go away and the blinking caret to go away, say resign first responder to the text field that is the current first responder, and it will go away. Okay, so that's how you control the keyboard. UI text field has a delegate. It has about actually 10 delegate methods. It can do quite a lot of interesting things. For example, when the keyboard comes up, most keyboards have a return key in the lower right-hand corner, okay? And when you hit that return key, you get this delegate method. Text field should return. It returns a bool. It's basically saying, should I do what I normally do when you press return? Because text fields are also controls. They can do target action, okay? So it's kind of asking you here, should I do target action? Should I, some control dragged to an IB action, should I send that? Okay, that's what it's asking here with should return. But one thing you can do in should return, you might return yes, but you might also resign first responder. Because when he hits return, you want the keyboard to go away. Because otherwise the keyboard will not go away when he hits return. Even if you have target action, it's not going to make that keyboard go away. All right, so it's very common that you want to implement a text field delegate just to make the keyboard go away when you hit return. All right. What other delegate methods does a text field have? You can find out every time it resigns first responder, it will send its delegate the method did end editing. So this is a good way to find out, oh, I better get the text out of there and go do something with it because someone hit return or did something that caused resign first responder to happen. So this method gets sent to you. In fact, this is probably more common way to get the text out of a text field than target action. Okay, is to implement its delegate, and in end editing, you get the text out of there. Okay, or you could even grab it out of there in should return if you want. So text field is a control. You can do target action, just control drag. It has certain events that can cause target action to happen, just like a button actually, and you can right click on a text field in the storyboard to see what it can do there. The keyboard, you can change the kind of keyboard. The keyboard, for example, there's a keyboard for entering URLs, and it's got a button on there, .com. Okay, I think it even has a button, HTTP, so that you can quickly enter a URL, right? There's another URL which is like a phone dialer, which is just a keypad, or a keyboard rather, that's like a phone dialer, so it just has the numbers or whatever. So you can specify that. And the way you specify those things is you don't send any messages to any keyboard object. You send it to any object that is using the keyboard that implements the protocol UI text input traits. Okay? UI text input traits is a protocol that has all these things shown here in it. And when you send it to something like the text field, it configures its keyboard to match that. All right, so if you want autocorrection in your text field where you're typing and you're mistyping and it's autocorrecting as you go, you can get that. Just set your autocorrection type there to .yes in your text field. So you're sending these vars are on text field, but they're on text field because text field implements the UI text input traits protocol. All right, and you can do secure text for passwords and all that kind of stuff. In other words, if you're looking to control your keyboard, don't look in text field per se. Go look at this UI text input trait protocol and you'll see what you can do for your keyboard. You can also set an accessory view in your keyboard, okay, a little view along the top of your keyboard that is just for your app. Okay, that's kind of fun. You just, again, this text input traits protocol thing. One thing about the keyboard, I'm actually not going to talk about this because of time. We'll talk about this in a later lecture. But the keyboard, when it comes up, it actually covers up your views. Okay, so you better make sure that text field is not underneath the keyboard. Otherwise, keyboard will come up and people will not be able to type in your text. And I see a lot of final projects that do this, where you do have your nice UI and you've got a bunch of text fields on there and you've got some text fields towards the bottom of the screen. And when I try to run your app and do it and I click it, I'm running it on a real device. There's no keyboard. I can't type in the simulator. Yeah, one thing about when you're doing text field, be careful, because in the simulator you can just type on the keyboard. But in the real world, a keyboard's going to slide up from the bottom. Okay, so students often will do their final projects, do the whole thing in the simulator. They only barely do it on the device, even though that's absolutely required for your final project, by the way. And they turn it in, and bam, they get dinged pretty hard because I can't use their app. Okay, because the keyboard comes up and covers up the text fields that they're wanting me to enter text into. So anyway, the way you find out about the keyboard and where it came over is using these observers. And you're basically going to observe the window, and the window's going to send you this little notification that says, hey, the keyboard just came up, and in the notification it sent you, there's going to be information about the rectangle that the keyboard used to cover you, and you have to move your UI out of the way. Okay? Hopefully you're in a scrollable thing like a table view or just a scroll view, but if not, then you just got to set the frame of your super view or something to move that thing up. Okay? Because it's your responsibility to make sure that the keyboard's not covering something that's necessary to use your UI. So when you're doing your final project, do it on a device, okay? Otherwise, you're very likely to run into this problem. So we'll talk about these observers, these notification center and stuff in a future lecture. There's other text field properties not related to the keyboard, like it does the auto shrinking and all that stuff that we saw with UI labels, so you can control that stuff with text field. I'll let you look at the doc to figure all that stuff out. Text fields also have a little right and left accessory view, these little overviews for like a search button or a little, you can put little exclamation points in there, things like that, so you can look for that as well. All right, so that's it. On Wednesday, I'm going to do table view, big old lecture with a big old demo, and that's what your homework's going to be about. Friday, we have a section. It's going to be on collection view, which I'd love to teach in main lecture because it's a really important class. It's very much like table view, but more flexible, a little more powerful than table view. But you kind of need to know table view first. That's why we do table view on Wednesday, and then the collection view on Friday. Then next week, I'll be doing the object-oriented database called Core Data, and you'll be integrating that into your assignment 4 to make your assignment 5. Okay, that's it. See you then.
For more, please visit us at stanford.edu.